Hello, I'm Miss Igo. Welcome to my classroom. In this video, we're going to talk about how to find the LCD, or least common denominator. When dealing with fractions, the numerator is the number on top and the denominator is the number on the bottom. So finding the least common denominator means we're going to find the smallest number that the bottom part of the fraction, the denominators, have in common, or the smallest multiple of that number. When we're dealing with just numbers, the easiest way to find the least common denominator is to list out a few multiples of each number. So a multiple would be when we multiply that number times another number. So if I were going to list out the multiples of 48, I would do 1 times 48, which is 48. 2 times 48, which is 96. 3 times 48, which is 144. I could do it again and do 4 times 48, and that's 192. Okay, let's stop there for right now. Now we're going to list the multiples of 72. 1 times 72, of course, is 72. 2 times 72 is 144. Well, I can stop there because 48 also has a multiple, which is 144. So that is the smallest number, the smallest multiple that these two denominators have in common. So 144 would be our least common denominator. When our denominators have other components like variables or polynomials in them, we need to look at each different type of factor separately. So in these denominators, we have numbers and we have variables. So let's look at the numbers first. We have the numbers 4, 3, and 6. So again, let's do what we did in the previous example and list out factor or multiples of those numbers. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Okay, let's do the 3. Let me do it like I did the other one. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And 4 times 3 is 12. Okay, so for 6, we have 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. And 4 times 6 is 24. So you just have to keep listing until you see the same multiple come up. Well, in my 4s, I see that I have 12. In my 3s, I have a 12. And in my 6s, I have a 12. There's no number smaller that they have in common. If I were just looking at the 3 and the 6, if I just had to find the least common denominator between the 3 and the 6, well, I could stop here at 6. 6 would be the smallest multiple that they have in common. but I need a common multiple between all three numbers, and so the smallest multiple that they have in common is 12. Okay, so when I'm listing my LCD, the number part of my LCD would be 12. When my denominators have different components in them, like numbers, variables, or polynomials, then I need to, in my least common denominator, I need to include the maximum number of times that each different factor occurs in each denominator. So the maximum number of times in these denominators, if you'll notice, every denominator has an A. The first one has an A, the second denominator has an A, and the third denominator has an A. So the maximum number of times that A occurs in any of the denominators is once. So I'm going to include A in my least common denominator. So my least common denominator for these three terms is 12A. Okay, in this example, we have for our denominators 5y to the third and 3y squared. Now, if you'll notice, in every time we're trying to find the least common denominator, we don't worry about the numerators. We don't care what's in the top of the fractions. We're only focused on the denominators. So we're going to look at each component separately. We have the numbers 5 and 3, and then we have the variables y to the third and y squared. So for our numbers, let's find the least common denominator by listing out the multiples. So the multiples of 5, or the first few multiples of 5, would be 5, 10, 15. The first few multiples of 3 would be 3, 6, 9. Okay, so I don't have any in common yet, so let me keep going. 4 times 3 is 12. 5 times 3 is 15. I just noticed that I wrote part of that incorrectly. 3 times 3 is 9, not 3 times 9. Okay, so there we have, now we've reached a multiple that they have in common. So 15 is my the smallest multiple that they have in common, so that's going to be part of my least common denominator. And now for our variables, we have y to the third and we have y squared. Okay, so as I said earlier, we want to include in our least common denominator the maximum number of times that each factor occurs in the denominators. So y occurs 3 times in the first denominator, and it only occurs 2 times in the second denominator. So we're going to put y to the third, the maximum number of times, in our least common denominator. So when we have exponents, when we have variables that are the same, we're going to use the one with the biggest exponent for our least common denominator. So 15y to the third would be our least common denominator. Anytime we have polynomials, meaning we have terms that are connected to each other with addition or subtraction, we want to make sure that our polynomial is completely factored before we find the least common denominator. Well, in this first term, our denominator is x plus 1. That's a polynomial. I'm going to go ahead and put that in parentheses just to remind myself anytime I have a polynomial, if it's connected with a plus or minus, it's like those two terms are stuck together. So I have this x plus 1, and in the other denominator I have 3, and I have x. So as I said before, we want to think about each different type of factor separately. So I want to look at my numbers, my variables, and any polynomials. And then I have to include every different type of factor in my least common denominator, and I want to use it the maximum number of times that it occurs in any one term. Okay, so if I look at my numbers, the only number I have is 3. So it needs to be included in my least common denominator. If, for example, this first term had, say, 5 times x plus 1, then I would need to find the smallest multiple that 5 and 3 have in common. But there's not a number in this other denominator, so I'm going to use the only number that I have, which is 3. All right, so then I'm going to look at my variables. Even though this is an x, like I said, it's a polynomial. It's a polynomial because it's connected to another term using plus or minus. So we don't think of it separately. We don't think of that as just an x. It's always stuck to the 1. It's x plus 1. So this x plus 1 and this x are different types of factors. So I'm going to include the x in my least common denominator. And then I also have to include the x plus 1. So we have to include every different type of factor in our least common denominator. So 3x times x plus 1 would be my least common denominator. In this last example, again, we have polynomials in the denominator. However, it's different than the one that we just looked at. Let me back up and show you the one that we just talked about. In this example, the x plus 1, that was a polynomial, but it was completely factored. If I look at the x plus 1, it's not a difference of perfect squares, and there's no common factor that the x and the 1 have in common. So it's completely factored. We can't factor it any farther. These polynomials, however, are not completely factored. In this first term, x squared minus 16 is a difference of perfect squares. Remember, when we have a binomial and there's subtraction in the binomial, if both terms are perfect squares, then we can use a difference of perfect squares to factor that binomial. So this can be factored into, remember, for a difference of perfect squares, we take the square root of the first term. The square root of x squared is x. The square root of 16 is 4. And we do one of each sign, one plus and one minus. Okay, now let me divide this so we can see what goes with what. In the second denominator, it is not a difference of perfect squares. It's a binomial and it's subtraction, but it's not a difference of perfect squares. X to the third is not a perfect square because in order for the variable to be a perfect square, it has to have an even exponent. 2 is not a perfect square, 8 is not a perfect square, so we can't do difference of perfect squares. So let's look to see if there is a greatest common factor. Well, remember, to find the greatest common factor, we need to find the biggest number that will divide evenly into both numbers or both terms. Well, the biggest number that will divide into 2 and 8 is 2. And then for our variables, instead of in the least common denominator, we use the biggest exponent. Remember, when we're factoring, we use the smallest exponent. So x squared. And then we write what we would have if we divided by our greatest common factor. Okay, so if I divided 2x to the third by 2x squared, the 2's would cancel. I'm taking away 2 of the x's, so there's an x left. Bring down my minus sign. 8 divided by 2 is 4, and then the x squares would cancel out. Okay, so now that side is completely factored. All right, so now to find my LCD, I need to use every different factor the most number of times that it occurs. Okay, so when I look across at all of my denominators, I have 2 as the only number. Okay, so that's going to be included in my least common denominator. Then for my variables, my single variables, that's not part of a polynomial, the only thing I have is this x squared. So that's going to be part of my least common denominator. Okay, now when I look at my binomials, I have an x plus 4. I have one x plus 4 here, no x plus 4s here, but I use it the most number of times that it happens. So it happens one time. And so I'm going to put it one time in my least common denominator. And then for the x minus 4s, I have an x minus 4 here and an x minus 4 here. So that means x minus 4 occurred one time in the first fraction and one time in the second fraction. So I'm going to put it one time in my least common denominator. And that would be the least common denominator for these two terms. And that's how we find the least common denominators. Thank you for watching.